Okay, so this is the question for a worked example for an RL circuit and to do all your currents, voltages and to do your powers as well. So I think the first thing that you would usually do, you'd draw down your circuit diagram. So that would be your first thing. So in your circuit diagram, you can add in all the values that you've got and all the information that you have. So you start with that. So you'd sketch out your RL circuit. That's your inductor L, your coil. It's 100 millihenries in series with your resistor, 82 ohms, and it tells you the combination is connected across a 240 volt, 50 hertz supply. And you can mark in where your current would flow as well if you like. The first thing it asks you to do is to work out the circuit impedance. So we're not at the stage we can really work that out yet because we don't have the number of ohms that's associated with that inductor there. So that's what you'd have to find out first. So you know the number of ohms associated with that resistor, but you don't know the number of ohms associated with that inductor. So we're going to do that first. And to find that out, the formula uses XL. So XL for inductive reactance equals 2 times pi times F times L. So 2 and pi are just numbers. F is the frequency of the supply, so that's that 50 hertz there. And L is the value of that inductance in henries. So 100 milli is 100 times 10 to the minus 3. So you just use your calculator to do that. So 2 times pi times 50 times 100 times 10 to the minus 3. And then put it into a decimal if your calculator's in maths mode. So that gives you 31.42 if you're going to 4 significant figures. Okay, so that's your kind of starting point. Because it's not a DC circuit, you can't just add these two values together. You've got to add them together as if they're phasors. So at this point, this would be the time that I think you'd be best to draw your impedance phasor diagram. So if you want squared paper, there's squared paper there. But this would be the point at which I would draw my impedance phasor diagram. So I'm going to put that to one side just now. And I'm going to draw out my crosshair for that. The bigger it is, the more accurate your measurement from it will be. So this is from impedance. Phasor diagram. And so far the information I've got is that R equals 82, that XL equals 31.42. And now I have to pick a scale. So what do you think would be a reasonable scale for this? Any ideas? The boxes in this are only 0.5 centimetre, so that would make it just up to about there, maybe there. I think I could go bigger than that. I think I could go 1 centimetre equals 10 ohms, I think. So my resistance, if you remember from last week, your resistance phasor will take you out here to the right hand side. So 82 ohms should be 8.2 centimetres. Just about there. That's my R. Your XL, if you remember from last week, will take you vertically upwards. 31.42, you're going to have to just do your best with that. That'll be my XL there. So my R, that's my 82 ohms. My XL, that's my 31.42. And then to get my Z, draw a wee dotted line out. From the top of your XL. Draw that down so it meets your R. And then your Z is from the start to the end. So that phasor there is my Z. And that angle in there is my circuit phase angle. So measuring my Z, I've got, let's have a look, about, on mine it's about 8.6, 8.7 centimetres. Yep. So 8.7 centimetres, 1 centimetre is 10 ohms. And that's by measurement. So I've measured it as being 8.7 centimetres. Each centimetre equals 10 ohms, so that should be about 87 ohms by measurement. A circuit phase angle, counting up on my protractor, 10, 20, I think it's about 20 degrees. So that's what I've got. They're both by measurement. If I want to do the same thing by calculation, I'll tuck that in here. How would you get Z by calculation? The inverse cos of R over Z will get you the phase angle. Z. Right, so you're going to use Pythagoras' theorem. So by Pythagoras' theorem, you would know that Z squared equals R squared plus XL squared. So to get Z, you're going to do the square root of R squared plus XL squared. What will be more accurate, your calculation or your measurement? Which will be more accurate, your calculation or your measurement? Calculation should be the more accurate. Okay. That'd be fair enough. Okay, so we'll work through this calculation. So we're going to do the square root, open your bracket, 82 squared plus 31.42 squared, close your bracket, equals. So 87.81. That's not bad. So what I'm doing in my measurement, I'm comparing this here by measurement to this by calculation. I think they're quite similar, so I'm quite happy with that. These two are similar enough for me. Then going back to using your SOHCAHTOA, looking at that angle, that's an opposite, that's an adjacent, and the size of this is the same as that. So the size of that opposite is 31.42. So to get the size of that angle, I'm going to use tan of the angle is the opposite over the adjacent. So the angle is going to be the inverse tan, or tan to the -1, of the opposite, which is the 31.42 for the XL, over the adjacent, which is the R, the 82. And I'm expecting my answer to be about 20 because that's what I've measured over there. So I'm going to do inverse tan, so shift tan 31.42 divided by 82. And I've got 20.97 degrees. So that calculation is very similar to that measurement there. So I'd be happy that my impedance phasor diagram is correct and my calculations are correct. They both kind of back each other up. Happy with that? And now I'm going to go back to my calculation sheet and I'm going to add these values back in. The calculated values, not the measured values. The calculated values, as we spoke about, are more accurate than these measured values. So I'll move this up. I'm going to take my calculated values and add them in. So I've got my Excel. I have got my Z, 87.81 ohms. I've not done my current, but I do have my circuit phase angle. Look at my circuit phase angle there. That's that 20.97. I can also get that from my other phasor diagram, so I'll check that when I go forward. But my circuit phase angle, 20.97 degrees. So I've got my answer to A, I've got my answer to C. I haven't done my circuit current. So that's what I'm going to do next, my circuit current. So for a DC circuit, you've got I equals V over R. For an AC circuit, I equals V over Z. So your V you take from there, that's supply voltage, 240 volts. And then for your Z, looking back, you don't take your R, you don't take your XL, you take this Z here, which is this Z here, this 87.81. To 4 significant figures. And it's a current, so it's measured in amps. So that's us now done. We've got the circuit impedance, we've got the circuit current, we've got the circuit phase angle. So now we're on to the voltage across each component. So VR, V equals IR, so you're just going to stick with that. So it'll be that 2.755 times the value of the resistor, that 82 ohms. Gives you 255.91. No, 225.91, I was wondering there. And to get your VL, you're going to do I times XL. XL being the number of ohms that you're contributing to that inductor. So that's 86.56. So now from this point, I would go and do my phasor diagram. So I've got my impedance phasor diagram, but now I'd want to go and do my phasor diagram. So your phasor diagram has all your voltages and all your currents in it. So this one will be for my phasor diagram. So again, the bigger you can draw your phasor diagram, the more accurate your drawing's going to be in your measurements. And we'll have a look at the values that we're trying to fit onto this phasor diagram before we choose a scale. So you're trying to fit, we'll have one scale for current, so I'll just say for my current 1 centimetre equals 1 amp. And then for my voltages, I'm going to include my VR, which will be 225.91, my VL, 86.56, and my supply voltage, my 240 volts. So what do we think? 1 centimetre equals what? I think 20 might not fit for me, to be fair, because if I made it 20, that would be 11 centimetres. And I'll be right over the top of my writing. So 20 is not going to work for me. 30 would work for me. Okay, so I'll put in my current one first. 1 centimetre equals 1 amp. So that's easy. Series circuit current's your reference phasor. So 2.755. 1, 2, about there. That's my current. Now your voltage across your resistor is in phase with your current. So 225.91 on my scale of 30. The way that I work out how many centimetres that's going to be is take my 225.91 and divide it by 30. So that gets me 7.53. So my phasor length is going to be 7.53. So it's about there. That's my VR. Then I'm going to do the same for my VL. So I'm going to take my 86.56. And that gets me 2.88. So about 2.9 really. That's my VL. And now I'm going to take my wee lines out, my dotted lines, the same as I did the last time, and find the intersection. And the phasor addition of VR and VL should give you your supply voltage VS, which is in there, 8 centimetres on mine. So by measurement, my V is 8 centimetres. My scale is each centimetre is 30 volts. 8 times 30 is 240. So that's worked out fine. That's also the circuit phase angle in there. So you could work that out the same as we did the last time. And I think we probably will, just to be sure. So we'll do by calculation, we'll do the circuit phase angle. And we'll use tan again. Opposite's your VL. Adjacent's your VR. So to get the angle, you do the inverse tan. So VL 86.56 over your 225.91. (20.96 degrees). Does that tie in with what we had before? Yes, it does. There it is, 20.97, 20.96. So that's pretty much the same. So that's all checked. So this is just a wee additional check rather than a thing that you must do. That's just a check. Now, looking at these two phasor diagrams as well, you should notice that they're very similar. One will just look like an enlargement of the other, but the shape should be very similar. So when you look at these two, it's just as if one's a zoomed in version of the other one. One can be bigger. It doesn't make any difference which one is bigger. But they should have a very similar shape because the angles are the same, the relationships are the same. So we've done an impedance phasor diagram, our phasor diagram. We have calculated our circuit impedance, circuit current, circuit phase angle, voltage across each component, the supply voltage using the values from part D. We've done that. And now, true, apparent and reactive power. So that's the new part for today. So your true power is P. Formula for that? VI cos of the angle. Your voltage is your 240 there from your diagram. Your I is that 2.755. Times cos of your circuit phase angle, which is that 20.97. So 240 times 2.755 times cos 20.97. So 617.4 watts. The next one I asked you for on the list is the apparent power. Apparent power's got the symbol S. And it's just S equals V times I. So 240 again, times your current, which is 2.755. (661.2). And that's volts, amps. And your final one is your reactive power, your Q. VI sine of the angle. And that's volts, amps, reactive. Big R or small r, totally up to you. And then just to make sure I'm absolutely right, as a final wee check, I'm going to draw a power triangle. So I'm going to draw it over here. Again, I'm going to choose a scale for it. Just going to make it quite easy. 1 centimetre equals 100 watts or something. My P goes across in this direction. Pick a starting point. My Q goes down the way. On that scale, my S should measure 6.6. Pretty much does, so I'm happy with that. And my phase angle should be the same. It should still be 20.97. That looks good. So that's just as a wee final check. Oh, and one last thing. That circuit phase angle, because it's an RL circuit, that should be a lagging phase angle. So it should, on all the calculations, your impedance phasor diagram and your phasor diagram. All done.